So let's do the section 1.3.1. We are in SRTM folder. From this point, we want to go back to the original folder. We can use the CD space double dot command. CD space double dot indicates that I want to go one directory above this. So I want to go to the parent folder. So the current folder is SRTM. We can say CD double dot, and now you are back to the GDAL tools folder. You can verify it by doing dir on Windows and ls on Mac or Linux to say, okay, now I'm back in the GDAL tools folder, and I want to now see what directories are available. And finally, we can go to the NAPE directory. Let's say cd NIAP and go here. And then I can list the files and see if all my files are available to me. So we have quite a few files here, and these are all heavily compressed JP2 files. We want to merge them into a single file. So let's just create the file list first. So let's just run this command where we just list the files with the JP2 extension and put them in a file called filelist.txt. So Windows people can run dir/p start.jp2 and put it on this file called filelist.txt. And if I go and check my directory, you'll see that I have a new file called filelist.txt. And this will contain just a list of all the files that I have. Here we have maybe 50, 60 files, but in practice, you'll typically have, if you download the data for California for NAPE, you will literally have 20,000 tiles like this. So if you want to even check what the data looks like, the only viable way to do this is first create a file list like this. Once you have the files, you can create a mosaic and preview that. So we're going to use our GDAL build VRT command to say, given this input file list, create a nape.vrt. So I'm going to do GDAL build VRT. And we're going to give the input file list command. This will be our filelist.txt, and we want to create this nape.vrt. When we are creating this VRT file, it's going to take the text file and create a mosaic out of this. One problem with kind of working with imagery files specifically is they typically don't have no data values. So it's a photograph, right? Photograph comes as a photos. If you fly a drone and take image, you don't know what is no data. So let me just do GDAL info on one of these files. Let's say output 15.gp2. And you can see this one is in a specific UTM projection, 5,000 by 5,000 pixel tile. Pixel size 0.6 meters, 60 centimeter pixel resolution. There are 3 bands, red, green, and blue. So this is like a visual imagery. There is no data value. Right? It's a JP2 compressed, JP2000 compression, but no data value. That means when you start working with this, you don't know what is no data, what is not. When you clip it, what is outside of the clipping region? You don't have no data. Also, when you do apply JPEG compression, if you have 0 values and 1 values, JPEG compression will mangle those values. So when you're working with imagery data, specifically the ones that don't have no data values, it's a useful technique to add a mask band. GDAL allows you to say, I have my imagery bands. Along with that, I'll add one more band, which will track all the pixels which are valid and which are not. So when you do some operation, GDAL will update that band to say 1 where things are valid, 0 where things are not valid. And all the GDAL commands, the visual software like QGIS will understand that and will set the pixels where the mask is 0 to be no data. So this is another way to kind of maintain the masking within your image. So if I want to do this, when I build the VRT, I add this option, add alpha, which will now add an alpha channel to my output. So when I run this, I get the NAP.VRT. Let's check GDAL info on that. And you can see I have the same 3 bands, red, green, and blue, but now I have 4th band, which says the color interpretation for this is alpha. So this band will be used to indicate what pixels are valid and what pixels are not. All the kind of manipulation you can do on these 3 bands, the 4th band will keep track of the mask. And QGIS understands this, ArcGIS understands this, all software will understand that this is a mask band. I'll treat them accordingly. Okay, so we've added this. Right now, we've just created a mosaic. Can we view this? Probably not. If I drag and drop this VRT file in QGIS, it may render after a few minutes because there's, again, a lot of data. So we can't see this. If I had a mosaic of the entire state, I cannot even visualize this. So, but we have a VRT file that says this is a whole mosaic. Let's create a preview image. We learned the GDAL translate command. We can say, I want to take this VRT and convert to a JPEG file. So I'll create a JPEG file just to see what this looks like. But I want to create a 2% preview. So I'll use this outsize option to say the output file size would be just a 2% of the original file size. If the original file size was 100,000 pixels, I only want 2,000 pixels. So I'll just give you a reduced file size, and I want the output format as JPEG. Just give me a JPEG value. When I run this, I have 4 bands. I have to tell GDAL which of those bands I need to take and create this JPEG image. JPEG image only takes 3 bands. There's no mask concept in JPEG. So I will say, select these 3 bands. So all GDAL commands have this -B option, which you can indicate what bands to select. And the way to do this is -B1, first band, -B2, second band, -B3, third band. So I'll select these 3 bands and give this as an input to the program, and we'll take those bands and create a JPEG image. So let's run this. So I had my input file size was 40,000 by 40,000 pixels, the whole mosaic, and now I got a 2% preview of that as a JPEG. And you can see that went pretty fast. I could create this. And now for the first time, I can see what this whole mosaic would look like. So let's go and see the folder. You can see I have this preview image, and I can now look at this. And I can see combined, all the tiles combined, this is what the region looks like. I can know, okay, this region, there's no data. This all tiles are blank. I had no way of knowing that before I could create the preview. And I can say, okay, this has the data coverage for the region I want. Every data is fine. And I can now proceed with my next steps. This is the trick that if you do not know, you will struggle when you have large data sets. When I process data, typically the data volumes that we work with would be a few terabytes. And there's no way of checking every file. So this was the first step where we ran this. The output would take 5 or 10 minutes to create, but then we get a mosaic and say, okay, we have the data coverage. If there are missing holes in the data, we would know. And then, either we would stop and ask for the data for those holes, or we can proceed if it was okay for us. So good first step to create a preview out of the data before we actually launch and convert this entire.